All right, welcome back for another deep dive.
Always a pleasure.
I have to say, I'm really excited about today's topic. It's one that's near and dear to all of us. Like literally, you, my friend, are quite the little scientist, always so curious about the world.
It's wonderful that curiosity is so important.
It is, and it's why I think you're going to love this topic. Today, we're diving into something you use every single day, water. You drink it, you splash in it. But have you ever stopped to think, what makes water? Well, water. What makes it so special?
It really is an incredible substance, isn't it? Water is fundamental to life as we know it. I mean, imagine a world without water.
I can't even, it's just everywhere. So let's start at the beginning, shall we? What exactly is water made of? It can't just appear out of thin air, right?
You're right, it doesn't.
Yeah.
Just like everything in the universe, water is made up of tiny, tiny building blocks called elements. Now, these elements are so small you can't even see them with a microscope.
They must be unbelievably small.
Yeah. They are. Think of it like this. Imagine you have a big, beautiful Lego castle. That castle is made up of lots of different Lego bricks, right?
Yeah, lots of different sizes and colors all snapped together.
Exactly. Well, water is a bit like that Lego castle. It's made up of tiny building blocks, but instead of Lego bricks, we call them elements.
Okay, so what kind of element bricks do we need to build water?
To build a molecule of water, nature uses two very special elements, hydrogen and oxygen.
Hydrogen and oxygen. I've heard those words before. They sound kind of scientific.
They do, don't they? But don't let the names scare you. They actually tell us a lot about what these elements do. Hydro, you see, comes from an ancient Greek word for water, and gen means to create or be born. So hydrogen is kind of like the water creator.
Whoa, the water creator. That's so cool. And what about oxygen? I know I breathe oxygen to stay alive.
That's right. We need oxygen to breathe, and it's also a key ingredient in water. It's like nature is saying, here's what you need to live. Oxygen to breathe and water to drink.
Nature's pretty clever, huh? So, two hydrogens and one oxygen. That's the recipe for water.
That's it. Two hydrogens and one oxygen, all linked together, just like those Lego bricks, make a molecule of water.
That's amazing. But here's the thing that always blows my mind. Water doesn't always look the same, does it? I mean, it can be liquid like the water we drink, but it can also be solid like ice. How does that work?
You're absolutely right. Water can be a real shapeshifter. We call these different forms states of matter. You already know liquid water quite well. It's what you drink and what fills up the oceans and rivers.
Right, and it's what I make a mess with when I spill my juice.
Exactly. Now, when that liquid water gets cold enough, something incredible happens. Those tiny hydrogen and oxygen building blocks start to slow down and lock themselves together in a very specific, tight formation.
So they get all cozy and huddle together.
Exactly. And when that happens, the water transforms into its solid form. Ice.
So ice is just frozen water. It's like when I put water in the freezer to make ice cubes for my juice.
That's exactly it. You're freezing those tiny water molecules into a solid block of ice. But water has another trick up its sleeve. Have you ever noticed what happens when your mom boils water for tea?
Yeah, it gets all steamy and cloudy. What's happening there? That's not liquid or solid.
You're a keen observer. That steam, or cloud, is actually water in its gas form called water vapor. When water gets hot enough, those little hydrogen and oxygen building blocks get all excited and start moving around really fast.
Like they're having a dance party.
Exactly. And they get so excited that they break free from each other and escape into the air as an invisible gas, which we call water vapor.
Wow. So water can be a liquid, a solid, or a gas. That's amazing. It's like water has secret identities. But why do puddles disappear after the sun comes out? They just vanish into thin air.
Well, not quite into thin air, but they do evaporate and become water vapor. Remember how those water molecules get excited and escape into the air when they get hot? That's what's happening when puddles dry up. The sun's warmth gives those water molecules the energy to break free and become water vapor. So the puddles aren't really disappearing, they're just changing form and becoming invisible to us.
So the water from the puddles is floating up into the sky as water vapor. Is that what makes clouds?
You got it. Clouds are like giant collections of tiny water droplets or ice crystals that have formed from water vapor in the atmosphere. Remember those excited water molecules that escaped into the air? Well, as they rise higher and higher, they start to cool down.
Why do they get colder higher up?
That's a great question. It's because the air gets thinner and colder as you go higher up in the atmosphere. It's like climbing a really tall mountain. The air gets thinner and colder the higher you go.
Oh, I get it. So as those water vapor molecules cool down, what happens?
Well, they lose energy and start to slow down, just like when water freezes into ice. And as they slow down, they start to clump together, forming tiny water droplets or ice crystals.
So they're not dancing anymore, they're huddling up for warmth.
You could say that. And when enough of these tiny droplets or crystals clump together, they form a cloud.
Wow. So the clouds are like giant fluffy collections of tiny water droplets or ice crystals. That's amazing. But what happens to all that water in the clouds?
That's where the real adventure begins. The water in the clouds doesn't stay there forever. Eventually, those tiny water droplets or ice crystals get too heavy for the cloud to hold.
So it's like the cloud is overflowing.
Exactly. And when that happens, the water falls back down to Earth in the form of rain, snow, sleet, or hail. We call this precipitation. It's like the water is saying, time to go home.
So it's like a big circle. Water evaporates from the oceans and lakes, forms clouds, and then falls back down as rain or snow. It's like a giant water party in the sky.
It is, isn't it? We call this whole process the water cycle, and it's happening all the time, all over the planet.
That's incredible. So water is made of tiny elements. It can change its form. It covers most of our planet, and it travels in a cycle. But why is water so important to us? We've talked about how amazing it is, but why do we need it?
That's a really important question. Water is essential for all life on Earth. Every living thing, from the smallest insect to the largest whale, needs water to survive. It's like the lifeblood of our planet.
Wow, it's that important.
It really is. Think about it. Your body is mostly made of water, and every single cell in your body needs water to function properly.
You're right. I know I get really thirsty if I don't drink enough water.
Exactly. Thirst is your body's way of telling you that it needs more water. Water helps to carry nutrients throughout your body, regulate your temperature, and keep all your organs working smoothly. It's like a delivery system and a cleaning crew all rolled into one.
So water helps me run and jump and play.
It does. And it helps you think and learn and grow too. And it's not just humans who need water. Plants and animals need it too. Plants use water to grow tall and strong, and animals need it to drink and stay hydrated, just like us. Some animals even live in water.
So water really is the magic ingredient for all life on Earth. We learned that water is made of tiny elements, it changes its form, covers our planet, travels in a cycle, and it's essential for life.
Wow, it's been quite a journey, hasn't it? But remember, the exploration doesn't have to end here. Keep asking questions, keep observing the world around you, and keep that scientific spirit burning bright.
You got it.
Yeah.
Until next time.